Okay, dear presenters, dear chair, thank you for your patience. Now we can start the session.
Okay, yeah, thank you. Sure. Good morning, everyone. So, welcome to 12th International Symposium on Software Quality. So, this symposium is mainly focused on software quality issue in modern software development process. So, in this session, basically, 4 different authors are going to present their own findings, and each presenter will get 10 minutes time for presentation and 5 minutes time for question answer. So now first I am going to invite the first paper of this session, and the title of this paper is Examine the Bug Prediction Capability of Primitive Options Matrix. So now I am requesting the author to present this paper. Yeah, please share your screen and we will start.
Hello, can you see my screen?
Yes, it is visible. Yeah, you can start.
That's good. Hello, everyone. My name is Edith Prengő. I'm from the University of Szeged, from Hungary. And the title of my presentation is Examining the Bug Prediction Capabilities of Primitive Obsession Matrix. The title tells you almost everything you need to know. So in this research, we studied 3 primitive obsession metrics that were introduced in earlier works and integrated these metrics into an existing open source bug dataset. Our aim in this research was to find out whether this extension affects the bug prediction capability of the dataset. My presentation is structured as follows. First, I will introduce you primitive obsession. Then I will introduce the 3 primitive obsession metrics. And in the last part, I will discuss the research questions and answer them. So let's see what primitive obsession is. This is a code smell. We know that code smells are not actual coding errors, but their presence indicate potentially buggy code parts and potentially bad code design. Primitive obsession itself means the overuse of primitive data types. The developer relies on built-in data types such as integers, floats, strings too much instead of creating small objects. Let's see an example here. On the left side of the screen, we can see a Java source code, which contains 2 examples for primitive obsession. This is an employee class which has 2 behaviors based on the type of the employee. So the employee can be engineer and a salesman. And this design where we decide the behavior of the class based on constant static primitive typed variables is called type code usage. So here this is a type code, and we decide the behavior of the class with a switch case statement. These type codes are widely used in development, but they are bad design because they violate the object-oriented paradigm. This is a much more object-oriented solution. So if we refactor this code on the left side to a class hierarchy where the behavior of the engineer and the behavior of the salesman is encapsulated in its own class. So this is one primitive obsession. And the other example for primitive obsession is the parameter list of these 2 methods. We can see that these parameter list contains 4 primitive data types, which also has the same name because in both methods, because they correspond to the same data. If we refactor these parameter list into the parameter object called workshift, we get much more maintainable and readable code. So we can see from this example that primitive obsession has multiple aspects. We cannot describe it with only one formula. So in our previous works, we developed 6 metrics to grasp the different aspects of primitive obsession. And in this current research, we use 3 of these metrics, the class level metrics, which I introduce you on the next 3 slides. So the first primitive obsession metric we used addresses the problem of the long parameter lists I mentioned earlier. This method parameter clone metric is used to detect the repetitive parameter type name pairs in the source code. If we detect multiple primitive parameter type name pairs, we report the class for possible primitive obsession. The second metric is called the static final primitive usage. This is a very general function that addresses the type code usage I mentioned in the example. So it detects the usage of every variable that is constant, static, has a primitive type, and has uppercase letters, because according to our examinations, these type of variables are most probably type codes. And here are examples for the not counted variables. So this is a very general and a little bit heuristic function. And our third metric is derived from this one. So it's called the static final primitive switch case usage. So we count the usage of static constant variables only in switch case statements, where the variable is used as a case label. Here you can see. So it's a derived function. These 3 are the primitive obsession metrics that we use for this research that we integrated into the database. But now let's see the actual research questions and the answers for them. At first, we get 58 Java systems from the aforementioned bug dataset and analyze these systems, calculated the primitive obsession metrics for them, and integrated these results into the dataset. We performed 10-fold cross-validation with Veka on the original and on the extended dataset, and this table contains the results. We checked every important attribute of the classifiers, such as precision, recall, F-measure, and we can see that the addition of the 3 primitive obsession metrics didn't alter these numbers significantly. We can see here a little decrease, but that is not significant. So we concluded that the addition of the 3 metrics to the already existing 61 metrics in the dataset doesn't alter its bug prediction capability. However, the second research question showed a different picture. In this research, we performed a cross-project evaluation. So we trained a model, a J48 model, on every Java system and evaluated this model on every other system. We did this for the original and on the extended dataset as well, and compared the weighted average F measure of these evaluations. I must mention that for this research we used only 29 systems, because we kept only one version of a system from the dataset. This next slide contains a very large table with the results. These numbers that you can see are the weighted average F measure changes. So we can see a lot of zeros here. This means zero change. the cells with the green background means a significant increase in the weighted average F measure, while the red cells mean a significant decrease. And there are numbers with green letters and red letters as well. These are slight improvements and slight deteriorations. So, what is this 0.25 means in this left bottom corner? Let me explain this to you. This means that that we train the model on the Xerxes system. This is one of the Java systems, so we train the model on it and evaluated on the system with ID1, which is the MCT Java system. And we get a model that performed 25% better on the extended data set. So we can here we can see from this table that in many cases the addition of primitive obsession matrix improved the overall bug prediction capability, especially for this Xerxes system. And here we can see another Java system that performs well. So for smaller data sets, the primitive obsession matrix can help the prediction. However, there are deteriorations as well. But if we summarize the results, the number of improvements exceeds the number of deteriorations. In the last research question, we wanted to find out whether the addition of primitive obsession matrix adds valuable information to the dataset. We calculated a correlation matrix for every attribute for the 64 attributes, but that didn't show any correlation. So fortunately, so we also performed the principal component analysis. We calculated the first 20 principal components and also calculated the factor loadings for these principal components. A loading represents how much each original attribute contributes to the corresponding principal component. So this table contains only the portion of the loading of each principal component. We show here only the 5 metrics that most significantly contribute to the principal components. And as you can see, the 3 primitive obsession metrics are among them. So these 3 metrics are among the top contributors. So we can summarize from this research question that the primitive obsession metrics add valuable variance to the dataset. Now I want to summarize my speech. So in this research, we integrated 3 already defined primitive obsession metrics into a bug dataset and asked 3 research questions. And in case of cross-project prediction, we could improve the prediction ability in 28% of the cases. However, on the whole dataset, we couldn't find improvement, but this cross-project prediction is promising if we can work only with smaller datasets. In the future, we want to try out other classifiers, and we also want to work with different versions of the same system, of the same Java system, and we also want to investigate which systems are good for should we select to make the prediction better. Thank you for your attention.
Yeah, thank you. So anyone has any question? Any question? Anyone? If you have any question, you will unmute your mic and please ask. Okay, so I think no one has any questions. So now I have one question. So when we are going to add the matrix, whatever the matrix you are defining here, we are going to add those matrix. Okay. So when we are adding the matrix, basically we are increasing the complexity of any model. We are increasing the complexity of any model. So have you done the cost benefit analysis? Yes, if you are going to insert some matrix, or if you are going to add some new matrix, have you done some cost benefit analysis? Because we are going to put how much cost and how much benefit we are getting. So have you done any type of experiment on that?
No, we haven't done. However, we wanted to done it. So we didn't measure it properly, but the calculation of these primitive obsession matrix is cheaper compared to, for example, the L-com matrix and so on. But these are only just our estimations, and this needs a proper computation and future work.
Okay, but you have used only one single classifier, J48. Why you have not checked for the other frequently classifier like logistic regression, decision tree, name-based classifier? Because these are the frequently used classifier in this domain.
Yes, that is a good question. We didn't. We used only this J48 because the original data, the creators of the original data set used this classifier, and we wanted to make the results comparable. But we also want to check out other classifiers in the future as well, because maybe J48 is not the best for our purpose.
Okay, thank you.
Thank you.
So now I'm going to invite the second paper of this session. The name of this paper or title of this paper is.
No, you please.
Yes.
Invite to the other authors. Love. Ask to the any other authors who is present in the session can ask any question.
Yeah, I have already checked, sir. So I think no one has any question.
So, no question. It's okay.
Yeah,
It's okay.
yeah.
It's okay. Go ahead.
Yeah. So now the next paper is, the title of the paper is Novel Approach to Test Case Prioritization for Software Regression Test. So please start your presentation. Share your screen and start your presentation. Yeah, can you please start?
Yes, I'm starting.
Yes, sure.
Can you show my screen?
Yeah. Please start.
Okay. Good morning, everyone. My name is Tülin Boya. I'm from Yıldız Technical University in Istanbul, Turkey. And my studies topic is a novel approach to test case prioritization for software regression test. Large-scale software constantly evolves to adapt to changing business requirements. A software development process of such software project includes an endless loop of deleting, updating, or adding new elements. And we can show a life cycle for software developing. Regression testing aims to detect maximum error in software system with the minimum time and effort. Literature introduces several great works for this purpose. The regression testing for prioritizing test cases is used to determine the best order that saves money and time when they are run with their best order. Software system using regression tests are tested on all codes and modules again, even if a teeny change occurs in the code base. Developing different methods in regression test case prioritization techniques will contribute to software engineering. For this reason, we study a test prioritization method within the scope of this research. We focus on the problem of prioritizing test cases by using metrics such as working time, number of errors, best test results. We propose a method to prioritize test cases. The main purpose of our study is identify the errors as soon as possible by prioritizing the regression test cases. The main research questions are: How should error situation evaluate in the test scenarios which have an important effect on ordering test cases? And how should the running times and fault detection times of test scenarios be evaluated? How should past test effectiveness be determined on the new test sequence? At this point, we chose past test effective another text. It means this approach based on history. How should the efficiency of ordering of test cases be measured? And how does prioritization of test case affect resource utilization? And in soft studies, we suggest a method. So we can show our method in the figure. Our method has some modules. Various workflow steps need to perform to validate the proposed study. Uh, in our studies to detect the errors in software with a regression test as soon as possible. The first step is to provide a regression test data set applied to a software system. It should contain test cases that contain test scenarios group within the regression test and control the whole system. Within the regression test, data set applied for an existing software system. Initial data to be used in the prioritization of test cases are created. And the regression test is then run without any prioritization work, mean randomly. So after that, priority score is found for each test scenario by making test prioritization calculation from the data obtained through test runs. Test scenarios are ordered according to the test prioritization score. The test scenarios regression tests are sorted according to the prioritization account and run again, like a cycle. Firstly, we have dataset and we do some preparation for test case. We group them and we make some suites. After that, run.
Hello, just one second. So, are you changing the slide of the presentation? Because here we are not.
Excuse me.
Getting, yeah. Are you changing the slide of the presentation? Because in our case, it is only coming the single page. Okay. Yeah. Now we'll start. Yeah. So now it is coming.
Now it's okay.
And now it is okay. Yeah. Please. Yeah. Please continue. Yeah.
Oh. Okay. So I'll talk about the figure. We can a figure about our methodology. It's some module, and we have to do some work in all of this module. And I will explain detail about module. The first, the test case preparation. Regression tests include test sets grouped by related test scenarios. There are one or more test scenarios in each test set. We can show here. Each test case checks at least one error condition or a different count of situation. It's not a stable count. Multiple subconditions are also checked according to the process steps in the scenario. The number of situations controlled by each test scenario is considered as the size of the scenario. In the first step, error condition that it controls for each test scenario is determined first. The number of cases checked by the test scenario and number of errors detected are used prior to the test cases. Each scenario can be controlled with different error conditions from the control error situations, and the same situation can occur in different scenarios. In our study, the number of control situations is used as the size of the scenario. We call each of test scenario size of the test scenario. First, in second module, test case reordering module, we have to reordering all of test cases because we run tests randomly first time, and we get results, and then we order it all of scenario and differently ordering, we will run again. First regression test consisting of randomly ordered test cases is run on its original form without any prioritization of test cases. Second, data from test run results are recorded. Third, for each test scenario, the runtime, the error detection time, the size of the scenario, the number of errors detected is used in the prioritization score calculation. The test cases included in the regression test prioritize the amount of error they have detected in the past and the speed of error detection. The result that data to be used in prioritization calculation is analyzed, and the new order of the regression test is obtained. This is our cycle. Now, another module, we have to calculate for the priority each of test case. And error detection rating method we propose, error rates detected in the past are evaluated to prioritize the test scenarios. Our study focuses on the calculation of error detection rates, and the unique method is recommended. Error detection rate is calculated as follows. We will call E for the tested scenario, and we will call T time to be tested, and short names EDC means error detection capacity, EDC means error detection speed, and we refer EDR error detection rate, and priority score for scenario E at T time we will call RE-ET. While calculating the error detection rate, it was aimed to further refine the EDR score by taking into account the error detection rate of test cases. So we can say we have a two-part information. We can see here. Firstly, we have to determine how is speed this scenario and what is the capacity this scenario. For example, we have a simple data here. We have two test cases, and first test case checking two states, and for this testing only detect one error. So it get a point 1/2. We can see here, and the other part is for the EDR point. This scenario is 46 execution time, and it can detect for one error in a 21 minute 1 seconds. So it get another point because we want to priority quickly scenario. So the first part is here, and the second part inform. We will use approach based on history. So we use the previous point. During the first regression test, no test cases were tested before, so the error detection rates are unknown. Therefore, priority is determined as 0 for each test cases. During the second regression test, we can see here the error detection rate measured during the first regression test is set as a priority for the relevant test cases. In the later regression test, after t equals to 2, after the 3, the error rate measured during the previous test and the predetermined priority value were the alpha parameter, which takes value between 0 and 1. Assign a weight for the last calculated fault detection rate with alpha parameter priority value. The higher alpha value allows more permanent memory of previous error rate calculation to be considered. When this value is 0, the priority of a test case is always equal to the error detection rate calculated in previous test. at higher alpha values, not only to provis, but also provis the calculated error detection rates effective priority calculation. So our evaluation is in a real-time software. We conducted an experimental study on the OBS software regression test dataset, which we have obtained from Testurium, which is a web tool to run regression tests. For our study, the OBS software regression test, which is under development, was used as a dataset. The regression test consists of 14 test teams and a total of 73 test scenarios within the test sets. A total of 90 error conditions are checked. And we report after all running, all scenario is point, priority score, and check states, number of errors detected, and error detection time.
Yeah, you had 2 minutes left, so please try to summarize within a 2 minutes.
Okay. So after all this work, we measured effectiveness, is it work or not, and APVD metrics we used. So we can see the results after 3 tests running. We get really good result, and in almost half of the regression takes time, we detect all error. So our results are that our method improves the error detection rate of test sets. Even in the most complex situations, this improvement can be applied. With the improvement in the error detection rate, the cost and effort spent on a regression tests are also reduced. There may not always be sufficient resource to evaluate all test cases. In such cases, it is very important to use resource efficiently and to detect errors as soon as possible. And our method only source according to the error rate detected in the past. In addition, various characteristics of software units such as code coverage, code size can be considered. Thank you for attention.
Thank you. So anyone has any question? Anyone, any question?
Yes, I have one question, but first you have to go ahead.
Yes, sir. Please ask. After that, I will
No, first you can ask. First you give your comment first.
Yeah. So in this paper, basically you are going to prioritize the different types of test cases. So have you compared your results? Means after doing this operation, can we get any type of benefit? So have you compared without prioritization, and after that, have you compared your result?
Yes. We made the implementation with a web application, and we tried another scenarios, and during 2 months we compared a lot of situation, and we determined which is the best. And also I talk about alpha parameter. We changed it. We changed formula. We show everything, but I only present a little part because really time.
Okay, because I have not seen your conclusion in your presentation, right? After methodology, you have just skipped it. Why?
Excuse me, I couldn't understand very well.
Means go to your slides. Have you removed the slides? Where is the conclusion?
This what was wrong? I couldn't understand about my presentation.
Yes, your presentation. What is your conclusion? What is your concluding remarks that you achieved something? What you really achieved something with this work?
Anybody? You can see the other audio.
What?
Actually, I couldn't get the presentation I used with template is wrong.
No, it is not wrong. What is your concluding remarks? What is your major achievement in this work? I have not seen in your presentation.
Okay, sorry. Yes, it's A plus.
No, I'm asking what is your major contribution in this work?
Major contribution.
Yes.
It's the I I I talk quickly end of this. It's contribute to software engineering to priority regression test, and we will get money and time. Actually, a regression test is really essential in a software system. So we want to with minimum time and effort this regression test. So after this, if we can use this method, we can detect error, minimum time and minimum effort. So we reduce cost, we reduce time.
Okay. It's okay. It's okay. You have reduced the cost. You have reduced the time. It's okay. It's okay. Thank you so much for the presentation. Love, go ahead.
Thank
Yes.
you. I'm
Thank
really
you.
glad to be here. Thank you. And
Yeah. So
it's
now, yeah.
my first time.
You are welcome. You are welcome. Next time you will present well.
Yeah. So now I'm going to invite the next paper. Okay. So the cost estimating method for agile software development. A cost estimating method for agile software development. So now can you please start the presentation?
Sharik is there or
Listening me?
who is presenting this paper?
Sir, I am presenting the paper.
Okay, Sharik.
Yes, sir.
Yeah, but why you have not changed your name on the GC platform? It's okay. Go ahead.
Sure, sir. Is it visible to everyone, the presentation?
Yes. Yeah. Please start.
Yes. Okay. Okay. Well, the topic of our paper is Agile Cost Estimation Method for the Software Development, and the co-authors are with me, the Sanjay Mishra, Professor Sanjay Mishra, and the Pinriza Speticia, Paula Riza Kolpas, and the Mayank Mohan Sharma from the USA. The paper is related to the cost estimation techniques in the software development and the estimation of the projects related to the user stories and so on. Now why the screen is not moving to the next?
You
What
can
is the main issue?
just to read your presentations.
Okay, sir. Now, here the introduction related to our paper. The Agile was invented to improve and overcome the traditional deficiencies from the software development. The main reason to introduce the Agile methodology to overcome the deficiencies that the developers or the other estimators are facing from the very long time in the future, in the past. So to overcome all these issues, they proposed the Agile methodology and then the different kinds of estimation techniques proposed by the different researchers in the Scrum or Agile estimation. So the agile methodology is the main and other you can say the concept to dwell in the software industry is to create a very healthy relation between the software developer and the client. To facilitate the client and satisfy the client is another feature of the agile methodology with respect of the accurate cost estimation of the project. So the agile methodology increases the interaction between the developer and it makes software product defects free. It means that the client give change requests at any stage of the project and the developers fulfill these changes and to complete the projects as per the client requirements without the defects or without any error in the project. So the agile method is fast and becoming more popular because of its feature and the flexibility. The feature mostly I have found in that study are two that I already mentioned: the cost estimation, the accuracy of the project estimation, and the client satisfaction with respect of his desires and requirements. The study shows that the agile software development model is a very efficient and effective software development strategy that easily accommodates user changes but is not free from the error or shortcomings. Here, the shortcomings or error means that still some issues related to the estimation in agile that I'm going to address in the next slides and mention in the paper. The study mostly the mostly estimation techniques used in the agile methodology are the planning poker and the effort estimation. In the planning poker, they use some Fibonacci numbers to assign the different numbers to the user stories, and then they compute the actual effort or estimation required by the team to complete any user story or the overall the project. The effort estimation is a method in which they only compute the efforts that required by the developer or the team, Scrum team, to complete a user story. So these two kind of techniques mostly used by the researchers in the agile estimation, and we also referred these studies and extended. We studied that they proposed new model for our work to conduct a estimation study. We conduct a study on real-time projects that we are going to mention in the next slides related to the software industries and for different projects. We thoroughly explain these projects with the limitations of techniques, and the study proven that the traditional and all estimation approaches, the all estimation techniques here mean by the planning poker and the effort estimations, have some limitations that still need to be resolved or overcome from the agile methodology. Now here a little bit of introduction about the agile model. Agile model used for the efficient development since introduced in the software engineering. Agile has more fame other than the other SELC model due to these some unique features that do not find in the other SELC model. Agile used for cost and time management for software development. There are so many cost estimation techniques in Agile proposed by the research community, but the mostly used by the researchers or preferred or referred by the researchers are the planning poker and effort estimation. Here these two estimation techniques, some characteristics. It is a user story. It is used for the effort estimation. It is an algorithmic estimation approach. In Agile, there are two kinds of estimation techniques we studied. One is algorithmic and the other one is non-algorithmic. User story is an algorithmic technique. I also explain here what is the difference between the algorithmic and non-algorithmic. The non-algorithmic estimation technique is the technique where there is no numerical work or equation work used to estimate the project estimations or efforts of the team or developers. But the algorithmic technique is a technique where they are using some equational models, some algorithms, or some any other concept. Like the currently people are researchers also using fuzzy logic concepts, multi-decision making criteria technique to find the efforts of the team related to the project. So these all kinds of techniques who involves the algorithms, equational models, or any mathematical form are known as the algorithmic techniques. So here the user story is the algorithmic techniques. This technique still in use of agile estimations, extended to make new techniques such as velocity technique. This user story technique is still used to extend to make new or to overcome the issues of the estimation in agile software development. Velocity technique is one of these examples. It is used to find the efforts of the developers, that how much time or how much effort they need to complete a project or a user story. Planning poker is another second technique in the agile estimation. It is somehow related to the algorithmic technique due to the Fibonacci numbers used in this technique. But on the other hand, it is completely a non-algorithmic technique. Here are some giant software industries that we use for our model or to find the results related to effort estimation. We collected the case studies from the software industries as mentioned in the table. We have collected the case studies by the interview sessions with the developers. Due to the COVID-19, somehow it is very difficult to personally visit the software house. So we collect the data by the interview sessions or by the emails. Survey forms, we highlight the cost and projects related issues. We design some kind of a form to get the project's data to apply our estimation method on these projects details. Now here are some features that we completely use in our method to find the accurate effort or cost of the project. Number of user stories. First, we use to find the exact number of user stories that highlighted by the client. Then we find how many user stories our team can done in a one day. Due to the complexity of the user stories, we differentiate the easy user stories and the complex user stories, and then we find that how many user stories as per the easy or as per the complex we can do in a day or in a month. So due to this methodology adopting this methodology, we find the accurate number of user stories that we can done in a day or as per week or as per the month. Then we find that how many developers are working on the user stories with respect of the easy and with respect of the complex. On some user stories that are easy, the developers or number of the developers you can decrease, but due to the some complex user stories, you need to you can say engage a full team to develop the user story. So the cost we find as per the salary of the staff or the developers that are working on the user stories. So daily number of the days inside a sprint time. We also come out find the sprint time, that how much time they need they you can say adopted or they can taken to fill a user story per day or per week. As estimation confidence. Here this is a very unique feature that we include in our agile estimation method that we do not find previously, I think, in the planning poker on the effort estimation, the CL. Here the confidence means that how much the developer have expertise to develop or to complete a user story. Is the developer has full skills or language expertise or the understanding related to the user story. So this means that how much the confidence of the developer to develop that user story, to complete that user story. Here the CL is estimating that confidence level. The metrics for the user story side. Here, as I already explained, that we are differentiating the ED user stories or the complex user stories. Here the metrics for the story size means that how much the story is complex with respect of its size and how much it is easy with respect of its size. So the metrics for the story complexity I already mentioned. Metrics for the friction factor and metrics for variable factors. Here the variable factors are means I explain in the next slide that is mentioned. Now here are some variables factors. The table is easily to visible. Hello.
No, I think it is not visible. The contents are not visible.
Yeah, but now it is. Now is it visible?
Now the same thing, the same problem. I think whatever you are changing, that is not reflecting here. Yeah,
I think due to the okay, thank you. Okay, due to the I think the high size or very huge values in the table, it is very not visible. Even I try to extend the size of the table, but out of the screen. Okay. Yeah. Now here, if we see very closely, then the table mentioned some factors. Here the last one, the metrics for the variable factors. Now here the table is showing the VB means the velocity, and the story of the points, number of stories, how many number of stories done by 1 day or week, working days, how many days they work for to completion of how many number of user stories, and the team's salary. I mean, how many numbers of developers they are working on the 10 user stories, and how much they are getting per month or per, I mean, the salary. Now the next one is the time, how many time they taken to complete a user number of user stories, estimation time, real cost. I mean, when they develop, real cost here means that once you decided the cost as per their stories and as per their working achievement, I mean the number of user stories they completed, you complete you compute the time and cost, and then when you deliver to the client and he again suggests some changes in specific user stories, and then when you again accommodate or fulfill all these changes, then the cost and time are ultimately increase. So the here real cost means that the cost that increase after the changes. So this is in this table, this is the value presenting this real cost, and then the estimated cost, and after that the estimated cost means how much cost actually required to complete the number of user stories. I mean here the 10, and how many efforts and how many costs required to complete 10 user stories. Now here the actual cost means the cost that decided at the initial time, and the cost that is happens after the changes suggested by the client. So here is the actual cost that is required to complete the projects. In these we can explain these projects, user stories, and details. Conclusion and future work. Software effort estimation model for the agile software development projects is discussed in this work. The model prediction is based on user stories. We totally work with the respect of user stories and find the efforts, developers' skills, and who can done which user story very efficiently and within the time and with very less cost. Which user story meets which developer's expertise. Here the main concept is. The concept is designed to meet the most of the features of the agile methodology, particularly updated versions or iterations. Here the updated version, the iteration means, as I explained, the changes suggested by the client on any user story or on the sprint or on the iteration, with the aim of the address to major issues faced by the agilists. I mean the following who the follow the agile. These issues are still facing by the followers. We have designed this method for the accurate estimation based on the developer's expertise and experience. Here expertise and experience means the abilities or capabilities of the developer or any team, and the skills to predict the accurate estimation of the effort to done a user story. We have revealed that the estimation of the user stories are almost accurate as per the method suggested in this paper. Now here the last one bullet is the future work, and the main issue that we still find in the agile estimation is the biased nature of the developers or of individuals in software industries. Here the bias means that, as I stated that in the first slide, here the planning poker. In the planning poker, this bias concept is still existing. Here the bias concept means that when the user stories divided or to the developers or team, they first check that what the value assigned by their seniors, and they ultimately support or give favor to that value, and they also point at the same value by us. We need at the same time done need by the top manager or senior developer, and the same time done by the me. They even do not check that the user story is easy for them or not. They always prefer the words or the values stated by their top seniors. Here here is the bias mean. This concept is still exists in agile estimation that need to be resolved or from the agile estimation. And here thank you.
Yeah, thank you. So anyone had any question? Anyone? Any question? Anyone? Any question?
Go ahead, ask your questions.
Yeah. So I have one question. So in this project, yeah. So in this
Yes.
project, Yeah, in this project, basically you are collecting the feedback from the developer. So
Yeah,
have you validate? Yeah, have you validate that whether the feedback given by the developer is completely 100% right? Have you validated that?
No, yeah,
Or you
yes,
are
we
going to
validate.
assume like or you are going
Yeah,
to
yes,
assume like yeah.
yes, we validate. In this table, you can find the, I mean, the calculated cost and the teams here they mentioned. The expected cost and the actual cost they required. We first with the use of the model we take their inputs related to the user stories, and then when they do the user stories, they are different from their expectations or the estimation that they highlighted at the start of the project. So with this way we will find different you can say values related to the cost and time from the developers.
Okay, so what is your final final conclusion? Means can
Yeah,
we take the feedback from the developer or can we use the standard method?
yeah, the final conclusion is that when you are taking the feedback from the developers, then do not make a very group discussion or a group estimation approach. Divide them and then take their individual inputs and then compute that how many developers understand the user stories very accurately, rather than to support their top manager or other colleagues. Here then the bias concept will be removed and the estimation will be more accurate for any project in Agile.
Yeah, thank you.
Okay, thank
So
you. Thank you.
anyone, any other question? Okay, thank you. So now
Okay,
we'll
thank
stop. Yeah.
Thank you. Thank you.
Yeah. So the last paper of this session is the novel approach for detecting web service anti-patterns using word embedding technique.
Who is
And
presenting?
I am going to present, sir. I am going to present this.
Okay, you know, none of your co-authors are ready.
Yeah, now no, none of there. So
It's okay. Go ahead. Go ahead. Go ahead. That's why I must be here.
So, sir, can you please check whether this screen is visible or not?
Yeah, it is visible. Go ahead.
Okay. Yeah. So, good morning, everyone. So, the title of this paper is A Novel Approach for Detecting Web Service Anti-Patterns Using Word Embedding Technique. And this is a joint book work with my PhD student, Sahiti, and one professor from BITS Pilani, Bhanumurthy, and two persons from industry, Vipul Kochar and Srinivasan Padmanabhan. And this project is funded by Testing AI Solution Limited. So these are the seminar outlines. So first we will discuss about the anti-patterns, what types of anti-patterns we are using here, then experimental data set, what types of framework we are using for the anti-patterns prediction, then result and analysis, and final conclusion. So anti-patterns is a simple term. If we are going to define the anti-patterns, we can define as a standard but ineffective solution to solve any problem. So it is a common response to recurring problem that is usually ineffective and risk being highly counterproductive. So in this work, basically we are working for the web service anti-patterns prediction. So can we predict the web service anti-patterns based on the WSDL file? Because when you are working for the software as a service, they will never share you the software code. They will always share you the WSDL file, that is also called as a web service description language. So there are many works related to the WSDL matrix. There are some works related to the WSDL to object-oriented matrix, and then we are using the object-oriented matrix for the model development. But if we are using the directly WSDL file, if we are going to consider the WSDL file as a text type of matrix, then in this case, can we predict the anti-patterns or not? And if we are going to predict the anti-pattern, what types of text technique we have to use? So in this work, basically, we are going for the 4 different types of anti-patterns prediction. One is called the good object web service, fine-grained web service, ambiguous web service, and kitty web service. So basically, we are going for the 4 different types of anti-patterns, and we are using the WSDL file as an input, and based on that, we are going to predict whether the web service containing some anti-patterns or not. So from this data set, if we are going to check, we have considered the total 226 different web services, and out of 226 different web services, only 21 web services suffering from the POWS anti-pattern. Rest of them 13 suffering from the STWS, 14 are suffering from the TWS, and rest 21 suffering from the CWS types of anti-pattern. If we are going for the overall research framework, so first we are using the WSTL5. After that, we are using the different types of text technique that is basically used to convert the text document, means the text that is called the WSTL file, to some numeric representation of the text document. So normally we are using the TF idea, but in this work we have also used the different types of word embedding technique like globe, cob, and escape graph. So these are the techniques basically used to convert any text data to numeric data. And after that, we are getting something called the text matrix generated. Means basically we are getting the number representation of the WSTL file. Once we got the number representation of the WSTL file, then we are also going to find the which are the important features are there. So we are using the three different types of feature selection technique. One is called the significant feature. We are going to check whether the individual feature has the capability to distinguish between the anti-patterns or not. Then we are also using the cross correlation analysis. If we are getting the two features are highly correlated, there is no need to consider both features. We are going to use single feature. Then we are also using the principal component analysis. We are going to find the new value of the feature that had the highest variance as compared to the original feature. So we are also using the PCA value, and based on this value, based on these three different types of feature selection technique, we are getting the new set of data or the new set of relevant feature. After that, we are also using the different types of data imbalance technique, because we have already know our data is suffering from the class imbalance problem. So we are using the smooth, borderline smooth, and ADS-YN. So we are using the three different types of data imbalance technique that is basically used to balance the data. And after that, the predictive ability of these techniques like the TF, IDF, globe, cob, and escape graph, three different types of feature selection technique, three different types of data sampling technique, we are going to compare with using the most frequently used classifier called multinomial name-based classifier, Gaussian name-based classifier, Bernoulli name-based classifier, decision tree, random forest, and we are also using the different assemble technique like bagging, extra tree classifier, ADA boost, and gradient. And finally, we are comparing the model based on the area under curve, because our data is suffering from class imbalance problem. So here, whatever the conclusion we are making based on the area under curve, not based on the accuracy and efficiency. So here we are using the four different types of anti-patterns, and we are using the four different types of word embedding technique that is basically used to convert the text data to numeric data. Same like that, we are using the three different types of data imbalance technique. One is called the smooth, borderline smooth, and adaptive synthesized data imbalance technique that is basically used to balance the data. After that, we are also using the three different types of feature selection techniques: significant test, cross correlation analysis, and principal component analysis. We are also using the number of classification technique to validate the models. So overall, this is the result we are getting if we are going to use the different types of word embedding technique and TF-IDF. Then in the case of TF-IDF, we are getting the better result as compared to cob, escape gram, and globe matrix. But if we are going to compare the cost benefit analysis, then in this case, TF-IDF will also take the huge cost as compared to the cob, escape gram, and globe, because the number of feature in the TF-IDF is huge as compared to the cob, escape gram, and globe. Second, we are also using the different types of data imbalance technique, and if we are going to check the area under curve, in the case of sampling technique, we are getting the better as compared to the original data. So what we are getting like that, if we are going to develop the model based on the smooth data or on the sample data, then definitely the predictability of the model will improve as compared to the original data. Same like that, we are also going for the different set of feature, and in all the cases we are getting the nearly similar result. Means what we are getting like that, it is possible to develop one model with less number of feature as compared to the all feature. Means there are some features are there that is not important for the anti-pattern prediction, because in all the three cases we are getting the similar types of result: all feature, significant feature, and cross correlation analysis. But the number of feature in cross correlation analysis is far lesser than the number of feature in all features. Then we are also using the different types of classification technique, and what we are getting like that, if we are using the sampling technique that has the better ability to predict anti-patterns as compared to the normal technique like the multinomial, Bernoulli, Gaussian, decision tree. If we are going to use the sampling technique that will give the better result as compared to this technique. After that, we are also using the ransom test analysis to test that whether the models developed by using these techniques are significantly same or different. And here we are using the two different notation. One means there is no any significance difference, and 0 means there is a significance difference. If we are going to check the performance of the model developed using COB and skip gram is slightly different from the TF-IDF, but the TF-IDF is giving the better result, so we will always consider the TF-IDF as compared to COB, skip gram and GLOW. Same like that, when we are going for the different set of feature, there is no any significance difference between the model developed using the all features with the cross correlation analysis, but the number of features in cross correlation analysis is far lesser than the original number of features. So definitely we will recommend to you the cross correlation analysis in place of original feature. Same like that, when we are going for the different types of sampling techniques, whatever the model developed using this sampling technique is slightly different or significantly different from the original data. Means this sampling technique has the ability to improve the predictive power of the anti-patterns prediction model. Same like that, when we are going for the different types of classification technique, then in this case what we are getting like that, assemble technique is giving the better result and is also giving the significantly different result as compared to the normal technique. Only the assemble technique like the bagging and ADA boost are giving the similar types of result, but in most of the cases it is giving approximately different result. If we are going for the conclusions, first what we are getting like that, the high value of the area under curve, that is confirms that it is possible to predict the anti-pattern based on the WSGL file. If we are going for the different set of feature extraction, then TF-IDF will give the better value of area under curve as compared to the other word embedding technique. Same like that, if we are going for the different set of feature, then cross correlation analysis means whatever the feature we are getting from the cross correlation analysis, that will give the better result as compared to the other set of feature. Same like that, if we are going for the different types of data imbalance technique, then smooth technique is giving the better result as compared to the original data. And if we are going for the different classification technique, then the assemble technique is always giving the better result as compared to the normal technique. And these are some selected references for the software anti-pattern prediction. If you have any question, then please ask.
Any question, please? Thank you so much, Love.
Thank you, sir.
Any question, please, from the audience? A lot of audience are working in this area, so the session was very, very fruitful for all of us. Any questions from the audience? Yes. What is the major difference with your works and the existing ones?
So in this work, basically we are using the text matrix. Whatever the work is available, that basically using the either the WSDL matrix or they are using the either the object-oriented matrix. So first they are converting the WSDL matrix to object-oriented software, and after that they are using the simple object-oriented matrix like CKJ matrix. But in this work, we are not using the any type of matrix. Directly, we are using the text. Based on the text, we are going to predict whether the anti-patterns is present or not. So that is totally different. Yeah.
So it is totally different, right?
Yes.
So what is your plan for this work? Are you going to confine only for this conference or?
No. So this is the initial. First, we have checked like that. Is it possible to predict anti-pattern based on the TF-IDF or based on this text to number matrix or not? Here we are getting the strong conclusion like that. Yes, it is possible. Now, future we are planning to use the LSTM type of network, CNN types of network, where we have to use directly text as an input, and then we will develop the model. We will also planning to use the sentence embedding.
Okay, sentence embedding process. It's okay. It is a ongoing work.
Yes.
Yes, and it has a lot of potential to do a lot of things. So I hope that you will stop presenting it to the conference and you are going to target it something solid for the general publications, right?
Yes,
so don't present the next version to the conference, right?
No, I'm planning for the journal.
Okay. So just to target for you. Any questions at all? Otherwise, at this time, this is the time for break, right? For how many times? I think the second session is starting QS 1015. It is already started, right?
Yes, sir.
Yes, Professor Milka. So I think we could proceed with the next papers if you're okay with that.
Yes, because it is already started. Today there is no any break. It's okay. So, love, go on. Peter Gal, as I can see that he's around, right? Peter,
Yeah,
are you
hello.
around? Yes, Peter.
I'm here.
Yes, you can go ahead for your presentation.
Okay, just give
Love
me a
is again
second.
taking the charge here, huh?
Yes.
Okay, hopefully you can see my screen.
Yes.
Okay,
Since how many years you are with the ICCSA, right? It is your 5th or 6th year.
in this conference, this is my first.
Okay, Peter is the other name. Okay. One more guy from University of Sajid was there. Okay, it is your first. Go ahead. You are welcome.
Thank you.
Okay.
Okay, so thank you. I would like to talk about the bug prediction capability of primitive enthusiasm metrics in this short presentation. But first, we need to talk about a bit of bug prediction. Why we want to do bug prediction and possibly how to do it. The first interesting approach for bug prediction is to help triage possible issues or bugs in source codes. In addition, not just locate these, but provide future predictions on newer code, if it's possible there will be a bug or not. For developers, this could be very handy during active development. And to do this, there are various approaches. One approach is to select a set of known projects with known issues. For example, calculate source code metrics for these, and using these calculated source code metrics for projects, train various machine learning models, and using these models, predict or apply the same source code inputs on newly written source code, which can predict should there be an issue in this function or class or not. This is the core concept for bug prediction. But to do this bug prediction correctly, as I mentioned, we need to have projects with known issues, and in addition, we need to calculate the source code metrics for these projects. In our case, in this research, we used an already existing unified Java bug dataset, which contains 66 various projects. And in some cases, these projects are multiple versions of each other. For example, project A version 1, project A version 2, 3, or 4. And for all of these projects, common source code metrics are calculated and at the class level, and classes are marked if they have a bug or not. Using this Java bug dataset, we selected 33 projects. The selection criteria was very easy. We only used the latest versions just to compress our tables in the paper. And the other aspect of our bug prediction capability is the primitive enthusiasm metrics, which is our previous work done by us. In this paper, in the previous paper, we plan to quantify the primitive obsession bets somehow. And our initial question was how primitive, quote marks, a given function is. And for this, we developed 3 slightly different metrics: local primitive enthusiasm metrics, global and a hot primitive enthusiasm metrics. Just to give a glimpse of how it is calculated, I've taken the formula from the paper. The local primitive enthusiasm matrix is calculated for a single method by definition. And the equation's left side, there is a relation calculation that is on the far right side of the calculation. So here, we calculate the number of primitive function arguments for the given method. We'll divide this by the number of methods the number of parameters in the same method. And on the left side, we calculate all of the primitively typed parameters in the whole class, in the currently investigated class, and we are dividing the number of parameters in the whole class. With this relation, we'll get a true or false indication. That is this a local primitive suspected method or not? So a true-false value. The global primitive enthusiasm metric is a bit different, where the number of primitive parameters are calculated not on the not the current class, but on the whole system. So that will be a system global true or false value. This way, the whole indication is always related to a given system or a given class in the system. And the hot primitive enthusiasm method, enthusiasm matrix, is calculated if the local, the LPA calculation and the GPA calculation gives the same true value, then it is a hot. It's globally a primitive, reinteresting method and locally in the given class. However, this metric is, these PA metrics are inherently a method level based metrics, but our unified Java bug dataset contains class level metrics. So for this work, we had to aggregate these PA metrics for each class. And then we can add the same new metrics into the existing dataset, and we can use it to train models and do bug predictions. But before this, we wanted to investigate how the primitive enthusiasm metrics and other metrics are connected or connecting to each other. For example, it is probably true that this new matrix has connections with the number of parameters or the number of methods in a given class, because we're building on top of these informations. So we first did a bit of investigation for multiple source code metrics correlating to the primitive enthusiasm metrics. As you can see on the table, the local, the global, and hot primitive enthusiasm metrics are closely connected to each other. This is not surprising. Similar things are calculated in each of these, especially HPA is depending on LPA and GPA, so there will be a strong connection there. However, in the other cases, there are quite a few instances where the correlations are almost zero or neutral. There are some interesting cases like Lion's code have a stronger correlations, or number of local methods, total number of lines of code. So these have connections. But overall, we can say, based on this table, that our new primitive enthusiasm metrics can provide additional aspects for source code metrics, and they are not too strongly connected to other metrics. Going further, to evaluate the strengths of the new metrics, we did a cross-project bug prediction. That is, we trained the model on each project which we previously selected and evaluated on the other projects. This was done with the new PE metrics and without the metrics, so the original source code metrics only. For each of these results, we calculated the weighted average F measure, and then the differences between the PE calculated weighted average F measures and without the PE metric values. And this resulted in a fairly big table, which on the left side, the rows are defining the system which was the training done on, and on the rows, columns will provide the evaluation project. And as you can see, there are quite a few cases where the changes in the weighted F measures are fairly small, 0, minus 0.01 or around these. There are cases where the F measure changes are positive, that is, it is the new PE matrix adds beneficial information in case of F measures. There are also some instances where the metrics are adding the new PE matrix does provide a bit of decrease in F measures, but overall there are more improvements in this case than there are decrease in the systems. Going further, we also investigated a different approach, not a cross-project bug prediction, but a prediction across multiple versions of the same system. This is done so that if a developer creates a software, releases version 1, they will find issues, bugs there, and in the next version, they want to use the previously known informations. They train their model on the older version and use the prediction on the newer versions. This was the core idea in this multiple version comparisons. And I've taken a single table from the paper where the training was done on the Velocity 1.4 version system and evaluation on the 1.5 and 1.6, and the same F measure changes can be observed. So there are positive changes in these cases. So adding the PEA metrics did provide beneficial information on the long run in the newer versions when trying to predict issues or possible issues. To conclude, we tested the PEA metrics for bug prediction, how useful it is. For this, we used a unified existing Java bug dataset. We checked the correlations with other metrics, which concluded that it does provide new aspects regarding to other metrics. We did a cross-project prediction, which also showed that it can improve the prediction capabilities in terms of F measure, and also a project version-based prediction, which, as the previous slide and table showed, also provided extra benefit in terms of improved F measure values in both cases. In the future, we also like to extend this research to different classifiers. Like in the previous presentation, someone mentioned the logistic regression-based ones, or different data sets and different languages. Thank you, and I hope I fit in my allotted time.
Yeah. So anyone, any question? Anyone, any question? Okay, so I have one question. Okay, so in this case, you are using some other type of matrix, right? From existing matrix, you are defining your own matrix, and then you are calculating the bug prediction. Yes, you are developing one model for bug prediction. Okay, and you are getting like that F measure you also improved. So have you compared your result with the previous work result or previous researcher result? Because there are also various ways to improve the performance of bug prediction. Like you can also use the feature selection. You can also go for the data imbalance technique. You can also go for the assemble technique. So there are various ways to improve the performance of the model. So have you compared your result with the existing work?
Yes, the comparison one was done on the same approach as this project-based prediction.
Yeah, so there are so many papers are there. If you are going to search, approximately 30 to 40 different papers are there related to the same data set.
Yes. This was the preliminary investigation. So there's not concrete data that, but it's in progress. So.
Okay. Yeah. Okay. Thank you.
Thank you.
Anyone, any other question? Okay. So thank you. So second paper, I am going to invite the second paper. The title of this paper is Empirical Analysis on Predicting Wave Service Anti-Patterns. using source code matrix and assemble technique. So anyone is going to present?
Yes, sir. Yes, sir.
Yeah.
I'm going to share my screen.
Sure.
So, hello everyone. Good morning. So, the title of our paper is an empirical analysis on the prediction of web service anti-patterns using source code metrics and ensemble techniques. This paper is being presented by me, Sahiti, research scholar from BITS Pilani, Hyderabad campus. And the other authors of this paper are Juhi, who is a higher degree student, and my supervisor Lakumar sir, co-supervisor Banmurthy, and Professor Santanu from NET Root. So this is the outline of our paper. Coming to the problem statement, so most of the software industries today are using web services to construct distributed software systems based on the service-oriented architecture. And these service-based systems need to conform themselves, adapt themselves through years to fit with the new user needs. New user requirements. This is resulting in the deterioration of the quality and design of the software system and resulting in the insufficient solutions called anti-patterns. So our work basically is to detect web service anti-patterns, and for this we are using object-oriented metrics and ensemble techniques in this paper. So before some years, detecting web service anti-patterns is a manual approach, which is very time consuming, and most of the time it has resulted in errors also, and this has been a big headache for software developers. So coming to the definition of anti-pattern is basically uh, can be defined as a pattern that tells how to go from a problem to a bad solution. And the presence of anti-pattern is associated with bad design and programming practices. So in this paper, we have taken 5 anti-patterns, and we have conducted several investigations to identify these anti-patterns in the web services. So these are the list of anti-patterns we have taken into consideration. So we have conducted our experiment on a dataset that is published in GitHub by one of the author Uni et al. And this is a publicly available dataset, and this is the distribution of different anti-patterns we have considered in the dataset. So if you have a closer look at the dataset, you can see that only 10 to 15% of the web services are having the anti-patterns, and remaining most of the web services doesn't have the anti-pattern. So this is normally classified as a class imbalance problem, and in the later slides I will discuss how we have handled this class imbalance problem. So this is the research framework we have considered in this paper. So first, the in the dataset, the web services are available in the form of WSTL files. So we have taken that WSTL files and we have used a tool called CKJM extended tool to compute Java, object-oriented metrics from the WSTL file. So CKJM tool, what it does is it will convert the WSTL file into, it will extract Java files from WSTL file, and it will compute the metrics for each of the Java file of the WSTL file. So to convert this Java metrics that are computed at the file level to the system level, what we have done, we have used aggregation measures, and using this aggregation measures we are computing the source code object oriented metrics for each of the WSTL file. And as we have already discussed, the data set is suffering from class imbalance problem, and to eradicate that we have used a data sampling technique called SMART and its variants. And after applying data sampling techniques, we have found that some of the features are irrelevant and or not at all useful for us in the detection of anti-patterns. So to remove such irrelevant features, we have applied feature selection techniques, principal component analysis, and RSA, and then we have applied several ensemble techniques to develop build the models for web service prediction. And finally we have done the comparative analysis and performance evaluation using box plots and Wilkinson test analysis and descriptive statistics. So this is how we have converted the WSTL file to the OVO matrix and how we have computed the data set. First, from the WSTL file, we have applied WSTL to Java tool, which will extract the several Java files from the WSTL file. And on each of the Java file, we have used CKJM tool to compute the OVO matrix. And after computing the OVO matrix for each of the Java file, we have applied the aggregation measures to convert the object-oriented metrics that are computed at the file level to the system level. So totally for each WSTL file, we have computed around 288 features. So these are the list of source code metrics we have computed using the CKJM extended tool. And after computing the metrics, we have used this list of aggregation measures for converting the file level metrics to the system level metrics. So these are the data sampling techniques we have used to counter the class imbalance problem. So we have used SMOT, borderline SMOT, SVM SMOT, edited nearest neighbor, and SMOT to map. Along with this, we have developed a model using the original data also to check if it is essential to use the data sampling techniques or not. And then we have used 3 different feature selection techniques to remove the insignificant and irrelevant features. And so these are the reduced set of metrics we have computed after applying different feature selection techniques. The first table shows the source code metrics that are selected after using RSA, and the second table shows the subset of features selected using PCA only for the GOWS anti-pattern. That is the first anti-pattern we have considered. It is showing the eigenvalue, variance, and cumulative value. We have used this in our experiment. And these are the different ensemble techniques we have used for building the predictive models. We have used bagging classifier, random forest classifier, extra tree classifier, AdaBoost, and gradient boosting classifier. So we have used all this for developing the predictive models for detection of web service anti-patterns, and these are the results we got. These are the box plots for accuracy, AUC, and F measure after applying the data sampling techniques. If you have a look at the box plot, you can see that the AUC, the accuracy value of the model developed after applying the data sampling technique is definitely better before applying the data sampling technique. And you can also see that the model that is developed using SMOT edited nearest neighbor is showing the better result. Similarly, this is the box plot for feature selection technique. So if you see this, it shows that all the models that are developed using the feature selection technique are approximately showing the same result. So it means that there is a need for applying the feature selection technique, but it is irrelevant of on which of the technique you are using. You can go for significant metrics or features after applying PCA or RSA. There is no much difference. And then these are the box plot after applying the classification technique. And here you can see that the model that is developed using EST3, that is extra tree classifier, is showing better result when compared to the models trained using other ensemble techniques. And this is the comparative analysis we have done using ransom test or Wilkinson sign rank test. It shows if there is one, it shows that the, the performance ability of the model considered is similar. If it is showing 0, it means that there is a significant difference between the performance value. So if you have a look at the data sampling technique results, it most of the models it is having 0 value. It means that there is definitely a significant difference between the performance value of the models developed using different data sampling techniques. And if you see the results of feature selection techniques, it shows that there is no significant difference. It doesn't matter what type of feature selection technique you are using, but it is necessary to apply a feature selection technique before developing the models. And these are the results for classifier techniques. Here it shows that there is definitely a significant difference between the performance between the models developed. And these are the descriptive statistics. So you can see that small TNN is showing better result with a median accuracy of 97.33. Similarly, if you have a look at the feature selection techniques descriptive statistics, it shows that the value is ranging from 94.3 to 95.3, and there is no much difference. But among the models we have considered for feature selection, significant metrics or the model developed using the significant metrics is showing the better result. And if you come to the classifiers, EST3, that is extraordinary classifier, the model built using extraordinary classifier is showing the better result with a median accuracy of 97.18. So these are our results. And coming to the conclusion, our major conclusion is the data set we have considered is suffering from class imbalance problem. So it is definitely necessary to apply any of the data sampling techniques, so that to balance the WSTL files which are having the anti-patterns with the web services that are not having the anti-patterns. And we have and if you take the results of the ensemble techniques, extraordinary classifier is showing the better results. And among the feature selection techniques we have used, there is no significant difference, but the model trained using features selected by significant metrics is showing the better results. So these are our conclusion, and these are the reference we have used for this work. So that's it. Thank you.
So anyone, any question? Anyone, any question? Okay, so I have one question. So have you compared your result with the normal technique like name-based classifier, decision tree, something like that?
Yes, sir. We have definitely compared it, and when we compared the results, we have found out that the ensemble techniques is showing better result when compared to the simple machine learning classifiers like naive-bayes or decision tree and all that. So ensemble is showing better results.
Okay, thank you.
Thank you, sir.
So yeah, so now I am going to invite the next paper of this session. The title of this paper is Evaluation of Integrated Frameworks for Optimizing Quality of Service in Serverless Computing. So can you please start your presentation? Anyone is there who is going to present? Yeah.
We can't hear you, Anisha. Who is presenting? Anisha? We can't hear you.
Just unmute your microphone. Yeah.
Please unmute your microphone. Go next. Who is presenting?
Am I audible, sir?
Yes.
Okay, sir. Sir, so myself, Dr. Ranjan Kumar Bera, and I am one of the co-author of this paper, Evaluation of Integrated Framework for Optimizing Quality of Service in Serverless Computing Platform. Actually, we have been working in this serverless computing platform, and we have compared the performance of different integrated framework that has been used to deploy the application in serverless computing model. And these are my outlines of the paper. And yeah, cloud computing. Cloud computing is a basic model where user will get the resources or computer system resources on demand, and such as data storage and computing power without direct active management by the users. Okay? And cloud computing, these are the features of cloud computing: virtualization and on-demand availability of the resources, and low cost service can be provided, and parallel computing. These are the features of cloud computing. and and what is the difference in serverless computing is one part of the cloud computing model. Okay. You can say serverless computing is one of the deployment model where the application is divided into different functions, and each function will be as the unit of execution rather than the total application. Okay. In cloud computing, the serverless computing is an execution model in which cloud provider dynamically allocates and then charges the user for only the computing resources and the storage needed to execute for a particular piece of code. That means what is the main difference between the cloud computing and the serverless computing? The serverless computing is based on the model pay on use basis. Means whatever the resources you will use, only for that you have to pay the bill. And this is consist of combination of backend as a service and function as a service. And main thing is that serverless doesn't mean that server is absent. Actually, server is working on the backend side, and which is totally abstracted from the user. That will be all managed by the cloud provider. And these are the few characteristics of serverless computing: abstraction, pay as you go basis, and stateless. All the application will be stateless because the application are divided into function, and each function will be the execution unit. Okay? And the scalability, and there will be less switching latency between the functions, and it supports diverse application, and it supports diverse language as well. And this is the serverless architecture. Application user will be there, and it will deploy its application through a API gateway, and with the help of few functions. That means basic thing is that it is getting the service function as a service rather than platform as a service or infrastructure as a service. It is getting function as a service, and each function will be executed separately so that they will be executed in less time, and they will and the bill will be done as per the use basis. Whatever the resources you will use, only for that only you have to pay, not for the fixed amount of resources. Okay. The main problem in serverless is the cold start. Cold start is one thing is that is whenever we are deploying any functions, a container will be developed. A container will be created from the server side, and through that container the function will be executed. Okay, the main time consuming process is in the creating the container, and that is known as cold start. And vendor lock-in is there. That is one issue is with the serverless computing, and security is also one of the main problem, and debugging and monitoring also one problem, because the application won't be executed as a unit. application will be executed as different functions. And yeah, you can easily visualize here. That is the main difference between the serverless computing model and traditional cloud computing model. In the traditional cloud computing model, the user will give the application through an API, and each application will be executed in a single server. Suppose application one will be executed in the server one, and application two will be executed in the server two, like that. But in case of serverless computing, what happens? The unit of execution will be the function. Unit of execution will be the function. Like this, in server one may be executed function of different application, like function one of application 3 and function one of application 1, function 4 of application 2, like that. Different function may be executed in different servers. Okay, so basically unit of execution here is one function. And these are the few papers we have considered, and actually this is a very trending area nowadays. This we have considered the recent paper from the 2021 only, and these are the tools they have used for measuring the performance of the execution model. Some of them use Amazon AWS Lambda architecture. Some of them use Microsoft Azure and GCP tool. These are the few tools are there they have used, and these are the related work we have considered. And function as a service. Clients upload their business logic and providers maintain the traffic routing and scaling, as well as mainly focus on the deployment. Means everything will be managed by the cloud provider. Okay, user need not to worry about the application execution. Only they need to deploy the functions. In function as a service, developers have very little control over the resources and the infrastructure. All the burden will be goes to the this cloud provider. The abstraction is one of the core features of the function as a service model, where set of instruction known as function abstract the implementation part of the business logic in an application. And each of the functions are executed separately with an independent manner, and each function will be independent manner, due to which that will be done by some kind of application that is known as container, which is also known as lightweight virtualization container. And this is a very special feature in case of the serverless computing model. And if you see this one is the sequence diagram, how actually an application is executed in the serverless platform, how a tool is using this one. First, client will deploy its application through a request. It can be through HTTP request or GET request or POST request, like that. Through a web API interface, it is requesting something, and that event will be redirected to the cloud provider. As soon as cloud provider get the request, it will be asked for the authorization to the client, and after giving all the credentials for the client, that authorization will be done by the cloud provider, and then this function will be deployed. And for each function, one container will be created from at the server side, and when the container will start executing, and that notification will be given to the back to the client, and then again this will be continue the process until and unless all the functions of a particular application will be executed. And after executing all the functions, the container will be deprovisioned, and that container can be used by the other applications also. These are the sequence diagram for serverless execution model. The problem is this one cold start. Cold start means it refers to the time required for the cloud service provider to create the container. Okay. And this is the most of the time is consuming in creating the container. Otherwise, the switching between the function is very fast. Okay, so within very short span of time, an application can be executed easily. The most time-consuming part of this process is creation of the container running the functions. And we have compared the performance of these tools. These are the serverless platform tools, Microsoft Azure and OpenWix and OpenFS. All are the open source tools which are easily available in the net. And we have deployed our application to all of these tools, and we have compared the performance in terms of throughput and in terms of mean response time. This is just a small comparison between all the tools, and they are supporting most of the language. And most of them are supporting Java, Python, and we have written our code using Java, using Python. We have written our code, and these are the very important point. The container, what kind of container they are using. Microsoft Azure is using Docker container, and Kubernetes container is used by the OpenX. And we have observed that this OpenX tool is very effective as compared to other tool in terms of small applications. And this is the graph we have obtained. Actually, we can set the number of invocation. This is one kind of parameter we can set in the tools, and we have set the parameter to number of invocation to 500 to 10,000 invocation, and it can be observed from the figure that IBM OpenX is from IBM company, and OpenX has the high throughput as compared to all of the other tools, and in case of high invocation also. In case of low invocation like 1000, you can see this one Amazon AWS little bit comparable with IBM OpenX, but rest of the invocation, in case of rest of the invocation part, this OpenX outperform other tools. And this is the graph for the median response time. We have compared the performance in terms of median response time, and we have set the value of the number of concurrent user, means how many concurrent application can be run at a time. Okay, that can be set. This parameter can also be set in this tool. And by setting this parameter, we have compared the performance, and it can be observed that OpenView takes less median response time as compared to other tools. In case of even 1000 concurrent user, 100 concurrent user. That means 100 number of applications can be executed at a time. So main conclusion is that the serverless framework in cloud computing offers a number of advantages, which include cost efficiency, scalability, low latency, and better responsiveness while deploying application to the server. Okay. And by comparing these tools, we have concluded that OpenFC is better as compared to the most of the tools. And other tools also there, but these four are the most popular tools, and we have compared the performance using these four tools only. And out of these four tools, OpenX is found to be better serverless framework in terms of median response time and throughput. And in future, we are planning to consider other parameters for evaluating this performance tools. And these are the selected reference we have taken. Most of the references are of recent paper we have taken. Any questions?
Yeah, so anyone, any question? Any question? Okay, so I have one question, simple question. So have you compared your result with the recent work?
Yeah, actually, no work has been done by comparing these tools. And actually, this work is totally new work. Actually, we have gone through the number of papers, but no work has been done in comparing these tools. Many tools are there. They are not comparing with different tools, but they are different algorithms are there. They have been compared, but different tools comparison is not there. So that's why we thought that we'll see that which tool is better for which kind of application. So for that purpose, we have done this work.
Okay, fine. Okay, thank you. Yeah. So
Thank
now
you.
next I'm going to invite the next speaker of this session. And the title of this paper is A Self-Adaptive Approach for Accessing the Criticality of Security-Related Static Analysis Alerts. So can you please start?
Yes, I'm sharing my screen.
Yeah, please share your screen.
Can you see?
Yeah, it is coming.
Yes. Hello all, I'm Elias Kalutsoglu. I'm a PhD student working in Center of Research and Technology LS, and I'm going to present you a self-adapted approach for assessing the criticality of security-related static analysis alerts. Software security is a serious aspect of software quality, and the A fundamental aspect of software security is the detection of vulnerabilities in the source code. Automated static analysis can be used for vulnerability detection, but it is underused in practice as it generates an important amount of false positives, false alerts. So the aim of our study is to propose both classification and prioritization technique to assess the security-related static analysis alerts using information from vulnerability prediction, static alerts, and user feedback. In bibliography, one can find several studies about actionable alerts identification, where machine learning models have been built to discriminate static alerts as actionable or non-actionable. These models are either classifiers that classify the alerts as critical or not, or regressors that rank the alerts from the most important ones to the less important. However, we have noticed a large drop in accuracy metric when actionable alerts identification tools are applied in previously unknown projects. Another gap is that little work has been conducted to assess alerts from a security point of view. There in this slide, you can have a look of the overview of the tool. The initial input is a software product. Then it is processed by both a vulnerability predictor and by a
Your voice is not coming. Can you please check from your side?
Is disconnected?
Yeah, I think it is disconnected.
Yes, I think this is the last paper of the second session. Presentation
Yes.
was going very well and very interesting results are presented. So meanwhile, we can talk each other if you have any questions or you may ask. Right? So there are some opportunities are there. The first thing is that there is a CCIS Springer conference. Deadline is gone, but if anybody have some good works, you are welcome to submit the papers. I hope all the authors have gotten the invitations by email. So still you can submit if you like, right? The second thing is that we have a lot of papers, some of them in Web of Science, majority of them in the Web of Science. One best paper is going to be a CI index journal with impact factor from the e-sessions, and so you will be invited, you will be notified after maybe 1 month or 45 days. There is a committee who is going to work on those one. But be sure that every year we are publishing some of the papers in Scopus and Web of Science index journals, right? And in addition to that one, that means this proposal, this special issue, we have also a lot of platforms. For example, if you are in something software engineering and security, are you back? The presenter is back.
Yes. My connection was lost probably. I didn't realize it.
Okay, please go ahead. Please go ahead.
Okay. From where? Did you see that slide?
Yeah.
Yes.
We will start.
Okay. So from the next one, the aforementioned security assessment model executes static analysis to identify security weaknesses like null pointer and exception handling weaknesses. Then it aggregates the produced by static analysis alerts and computes high-level security scores. This work is published as a paper as well. Regarding the vulnerability predictor that I mentioned, it is a machine learning model that tries to identify software components that are likely to contain vulnerabilities. It is based on text mining and the multi-layer perceptron. It outputs a vulnerability flag for every component along with the vulnerability score, which is the likelihood of containing a vulnerability for the component. In this slide, you can see the overview of the proposed model. This model gathers the outputs of the security assessment model and the vulnerability predictor, which are security alerts with the vulnerability scores, and then the label data is preprocessed and given to the model as training data. Then the model is trained. During the phase of model execution, a new project is arrived to the classifier, and the classifier outputs a flag equal to 0 for a non-critical alert or equal to 1 for a critical alert. It also produces a criticality score indicative of the importance of the alert. Finally, the model can be received users' changes and it can be retrained to assimilate them. For the purpose of training and evaluating our process, we use mid-sized proprietary projects written in Java. The PMD static code analyzer is used to detect security alerts, and then the alerts are labeled manually by the developers of this project. We gathered totally 1,200 alerts, 550 of which were critical. The features used for training are the rule names, the rule categories, and the severity scores produced by automatic static analysis, and also the vulnerability scores. The rule names and types are categorical features, so we needed to encode them to one-hot vectors. We equipped our tool with the capability to retrain the model using feedback given by the user. It is an important process as the model can assimilate types of alerts that were not present in the training data, and also because some types of alerts can be more important for specific type of software. In order to choose our model, we conducted a comparison study between different machine learning algorithms, finding out that the multi-layer perceptron was superior than decision trees, naive Bayes, SVMs, and random forest algorithms, with an accuracy over than 86%. For the evaluation process, we explored a case study where the original model was applied on the alerts of a real-world software product. Then we retrained the model based on developers' feedback, and we re-evaluated. We can see that although the initial model's accuracy is lower than its descriptive accuracy, it is still high enough. After training, we can see that the accuracy increases more than 4% in contrast with the initial. So, we designed and developed a machine learning model to classify automatic static analysis alerts to critical or non-critical, and it can also prioritize them using the criticality score. This model's accuracy does not drop massively when applied on unknown alerts, and even better, it can be improved after retraining the model based on user feedback. For future work, we aim to replicate our study on projects written in other programming languages, and also to use different static code analyzers and different vulnerability prediction models. Thank you for your attention.
Yeah. So, anyone, any question? Any question? Okay, so I have one question related to your framework. So you are using a term called bag of words, right? You are using one term called bag of words.
Yes.
Bag of words. Okay. So can you give the idea about what types of bag of words you are using? Means there are different ways to find the bag of words. So what types of you are using? Whether you are using the count vectorizer or you are going for the TF-IDM.
We have tokenized the source code into a list of words or tokens, and we assign to them their frequencies of appearance in the code.
Okay, means we are assigning a frequency, right?
Sorry?
What you are assigning after calculating the bag of words, what you are assigning?
The bag of words outputs are the vulnerability scores.
No, bag of words means simply you are taking collection of words. That is called the bag of words.
Yes, it's a collection of words.
Yeah. So a collection of words means why you are calculating the collection of words.
I can't listen.
Yeah, this one. Yeah.
What?
Why you are calculating the bag of words?
Why we are using bag of words?
Yes.
The model bag of words is the vulnerability predictor in this case. We tokenize the source code into a list of words and their frequencies, and this model can assign vulnerability flags to the files, to the software components. And then the vulnerability scores, along with the static analysis alerts, constitute the input to our final model, the assessor of criticalities.
Okay. Anyone, any question?
Yes, in fact, this is not a question, but you used it is something related to the security as well, right?
To security?
Yeah, it is a security related static analysis alert, right?
Yes, static analysis.
Static analysis. So, how do you define that it is means some contribution or in the novelty of the work?
Okay. We have noticed that static analysis, although it is popular, it is underused in practice by the developers because
Yes.
it produces a lot of false positives. So we designed this model to reduce false positive, and we give user the capability to give his feedback to the model and retrain it in order to assimilate his or her behavior. Because for every developer, some alerts might be less or more important.
It's okay. It's clear to me. Any other question? I think it is the last paper, right, for this
Yes.
session, right? So, SEPA 3 is starting is at 11:30. This means still 10 minutes is there, right? Hello.
Hello?
Yes.
Yes, moderator. We have, I think,
Yeah.
we have 10 minutes for the tea break, right?
Exactly. So we can start back at 11:30.
11:30. Yes. Okay.
Perfect.
So thank you so much for everybody. Anybody is working for the security. I have a Springer Scopus Index book at present. Confirm in Scopus Index AI for the security and forensic. It is totally free of cost. If you have good papers, you can submit. There's a lot of opportunities are there. You can contact me directly if you want to publish any more paper other than your conference paper here in ISSQ. Right? So in absence of anything, so we are giving you a break. We are offering you a virtual coffee. Next year, I promise you to provide the actual coffee, right? You know what I was thinking to go and boil some water and take the same thing here in my office. So sorry for that one. We will see you after 9 minutes, okay? It is a break time. If you want, you can be available. There is no any need to leave the room. And Wendy is not going to close it, right, Wendy? Guilo,
Yes,
don't leave the room, okay? Just to,
of course.
okay, everything is on, so we will see you. Thank you.
Okay. So see you in a few minutes.
Yeah, see you in few minutes. Love talk with me on the WhatsApp.
Sure, sir.
Great.
Welcome back.
Hello, Professor.
Yes, nice to see you again.
Yeah, so can I invite the next speaker?
Is the Maria is available?
Yes, I'm here.
Okay, Maria, the floor is with you. Love is handling
Okay.
this session as well again.
Thank you.
Yes, so I'm going to invite the next speaker of this session, the technical debit forecasting based on deep learning techniques. So can you please start?
Can you see my screen?
Yeah, it is.
Okay. So, hello everyone. My name is Maria Mathiudaki, and today I will present to you our recent work, technical depth forecasting based on deep learning techniques. This is going to be the main outline of my presentation today. I'm going to say a few things on the technical depth, and I will describe the problem that we're trying to solve. Afterwards, I will describe our experimental setup and methodology. I will discuss the results that we obtained, and I will conclude our work and discuss about the future work that we're planning to conduct. Technical depth was introduced actually by Ward Cunningham, and it was inspired by the depth of economic theory. It basically describes the quality compromises that are done throughout the software development lifecycle of a software product that can yield short-term benefits, but may negatively affect the long-term quality of the product. Now, forecasting the evolution of the technical depth is of paramount importance, as it can significantly contribute in timely decision-making and in estimating the point to which the software product could become unmaintainable. Now, in our previous work, we have extensively employed statistical time series and machine learning models in order to generate forecasts for the technical depth. And however, despite the fact that these approaches were proven able to produce such results, such predictions for up to 40 versions ahead, their predictive performance dropped significantly for longer forecasting horizons. So what we're trying to do in this work is to find out whether or not deep learning models are able to generate forecasts for the technical depth for long-term, broader horizons in the future. So moving on to our experimental setup and the methodology that we followed, we utilized the technical data set that was provided by Lenarducci's paper. Now, we used 5 real-world open-source Java projects retrieved from the Apache Software Foundation, namely the Ambari, Commons Codec, Commons CO, HTTP Components Client, and Mina SSHD. And here you can see some information about these projects. Now, for each project commit, static code analysis was performed using SonarQube, which is widely used tool for static analysis, to extract the technical depth indicators and the technical depth principle. Now, the technical depth principle is actually the variable that we're interested in. It's the variable that we want to generate forecasts for. And it is the time in minutes that someone needs in order to fix all code violations, such as code smells, bugs, and vulnerabilities. To construct the technical depth forecasting models, we followed a univariate modeling approach. That means that we took under consideration only the technical depth itself, leaving aside any other technical depth indicators. Also, we performed some data scaling because it is a crucial step that needs to be taken before machine learning or deep learning algorithms are applied, due to the fact that machine learning techniques produce better results when data are normalized. And last but not least, we applied a method called the sliding window, which is a method that allows for the model rather to take under consideration only the current commit of the data set, to be able to take under consideration the past few steps, the past few commits, aiming towards higher accuracy, of course. Now, the technical depth forecasting is a regression problem, as technical depth is a continuous variable and it should be treated as such. Multi-layer perceptron was employed in the current work, which is a supervised deep learning model suitable for such tasks. Experiments were performed for 5 up to 150 steps ahead, and we used the walk-forward train test validation. Mean absolute percentage error was used for the model evaluation. And also here on this table, you can have a look on the values of the hyperparameters of the MLP model that were chosen as most optimal when we performed the corresponding grid search. Moving on to our results. Here, we have visualized the mean absolute percentage errors that we obtained for all of the 5 data sets when MLP was employed, for 5 up to 150 versions ahead. We can clearly see that the higher the number of versions ahead we're aiming to predict, the higher the error that we obtained. This is something that we have also verified from our previous studies, and we do expect. However, what is interesting is that even for the case that we obtained the highest possible errors, which was for the mean SSHD dataset, the errors are still not very high. And if we exclude this case, we can even see that most of the errors are less than 8% for up to 150 versions ahead. And this is it's an outstanding result. Now, comparing the MLP model results to the results provided when 2 of our best performing models was the next step. And this means that we collected the 2 best performing models from our previous studies that we have extensively tested, which are namely the random forest and the ARIMA model. And here we can see that for up to 40 versions ahead, the 3 models provide similar results, with the ARIMA model providing slightly worse results. But after that, we can see an interesting shift, and we can clearly see and observe that from 60 to 150 versions ahead, the MLP regressor offers way better results. And we also wanted to see it in practice. And here is an illustrative example of the model execution for the 3 models that I just mentioned, the ARIMA, Random Forest, and MLP. What has happened here is that we have trained the models on the whole Ambari dataset, except for the last 150 commits that were used for the testing purposes. And you can actually see here that at the beginning, ARIMA model and MLP and Random Forest all catch the trend of the data. The ARIMA model quickly loses the track of the data. And after 40, 60 versions ahead, also Random Forest completely loses track of the data, whereas MLP keeps track of the data at a very good level. So in order to conclude our work and describe a little bit about the future, the adoption of MLP regressor was indeed a promising solution for enhancing the accuracy of long-term technical depth forecasting. For rather narrow horizons, we saw that MLP offers similar results to the ARIMA and the Random Forest regressor for up to 40 versions ahead. And then for 60 to 150 versions ahead, we saw that MLP model managed to fill the gap of demonstrating promising results. Of course, this lays the ground for further investigation, and we also wish to investigate the generalizability of our approach using real-world software applications that are written in other programming languages, because these projects were all written in Java. Or we also want to see what happens with projects from different domains. And also we want to investigate the performance of MLP technical depth forecasting to lower levels of granularity, such as package, class, or function level. So basically, this was it. Thank you for your attention. And if you have any questions, I would be happy to answer.
So anyone, any question? Any question? Okay, so I have one question related to the MAP value, mean absolute percentage error value. So in this case, we are getting the very high value of MAPE. So can we say whatever the models we are developing, that is feasible model? Can we say? Because we are getting very high value of MAPE. If we are going to check here, we are getting very high value of MAPE.
You mean in the paper, the rest of the errors?
Yes, yes.
We do get high values of these errors. However, I use here this kind of error because this is the error that we use most in order to compare this study to the previous ones. I don't know exactly why now. Have to look into it again to see why this particular error was high. But we don't focus so much on the high values of that error, but on the trend that they have, that they rise with the value of the versions ahead that we're trying to predict. But most of the times we do focus on this error. That's true, mean absolute percentage error.
Yeah, because based on the error, we have to decide the ability of the models, whether the model will predict the right value or it will predict some wrong value. And from the research, it was observed that so we can only consider the MAP value up to 8%, not more than 8%. Not more than 8%.
You're talking about what I just said on this slide about 8%?
Yeah. No, what I'm saying like that, you are getting the very high. If you are going to the next slide, go to the slide number 13.
Okay.
Next slide. Next slide. Slide number 13. Yeah, 13. Yeah.
So
no, it is not coming. Go to slide number 13. Yeah. This one. Yeah. Here you can see we are getting the MAP value approximately 50,000, something like that. Here you can see the MAP value have already mentioned. So I think there is something problem with this figure because we cannot get the MAP value 1,50,000.
I'm not sure I understand now about this.
Yeah, what you are saying. So just you can see in the figure, the y-axis, what you are representing the y-axis.
The y-axis is the mean is sorry.
Yeah.
Okay, you're absolutely right. This is not right. This is wrong. No, it's not a mean absolute percentage error. This is the actual values of the technical debt. I'm so sorry for this. It's wrong. Sorry.
Okay, thank you. Anyone in the other question? Okay, so now I'm going to invite the next paper of this session. How do the developer use the Java Stream API? So can you please start your presentation?
Hello, yeah, I will start sharing right now.
Sure.
Can you see my screen?
Yes, please start.
Okay. So good morning, everyone. I'm Joshua Nostas, and on this occasion, I will present the result of the investigation called How Do Developers Use the Java Stream API? The authors of this work are Juan Pablo Sandoval, Diego Elias Costa, Alexandre Virgil, and myself. The Java 8 version, released in 2014, officially introduced the notion of stream processing to Java programming with the Stream library. The Stream library provides a set of classes to support functional style operations on streams of elements. A stream is basically a view on a sequence of elements, objects, or primitives, organized by the underlying data structure, a stream source. A stream source can be of any data type, and developers process a stream by defining stream pipelines. composed by functional operations as shown in the example. Let's continue with the related work. Numerous studies have investigated how developers adopt language and API features. There are studies that seek to understand the breaking type safety in Go and Rust, or the use of the goto command in C. In the context of Java programming, Costa et al. Investigated how developers use the Java Collections API, and Masinanian et al. Investigated the usage of Lambda functions. These frameworks are directly related to how developers use streams. The work that is most related to ours is a work of Cachadurian et al., published in 2020, which we partially replicate in this study. Cachadurian et al. Have investigated the use and misuse of the JavaStream API over 34 Java projects and 719 code patches. Similarly to our findings, they have reported that parallelization is seldom used and that developers frequently use ordered streams, which are not optimal for parallelism. They also reported that developers favor more straightforward stream pipelines. In particular, we focus our analysis on answering the following research questions. What is the trend of the JavaStream library adoption in Java projects? And how do Java developers use streams in their projects? In particular, we were interested in the following questions. What is the most commonly used stream operations? What are the most commonly used pipelines? And what are the most common operations that developers do using streams? To carry out the mining of Stream API usage in a large corpus of Java applications, were used the following three-steps process. First, project selection, where we just select GitHub repositories of Java software projects. Second, detection. To detect the stream pipeline usage, each Java file was analyzed for all selected projects. And third, categorization. Stream pipelines were analyzed quantitatively and qualitatively, and their use was characterized. Using a type inferencer to identify stream usage is therefore appealing. Despite their solid theoretical foundation, using type inferencers in our context suffers from two different aspects: project dependencies and overhead. The study started with an initial sample of 10,000 most started Java projects from GitHub. In order to discard small projects, were initially selected for further analysis projects that meet the following criteria: projects not archived, disabled, or forked, projects with 3 or more contributors, and projects with more than 50 commits. For the initial 10,000 projects, 5,386 were left. Then, to discard educational or example projects, the first 3 authors manually read a project name and description to categorize each project. After this step, the sample was reduced to 5,096 projects. Then, a keyword filtering was performed on the projects that consist in reviewing each method call of all the Java projects. The JavaStream library provides a number of ways to directly create stream objects. The most common are auth, stream, and parallel stream. As a result, were found 2,189 projects that meet this criteria. Then, it was necessary to download the dependencies for each project. The dependencies were downloaded automatically from all the projects that use Gradle and Maven. The dependencies of 851 projects were able to be downloaded. Since the analysis highly depends on being able to determine if a method call is related to a stream object, we used only the 851 project as a base of our study. And finally, the Java symbol solver type inferencer was used to determine the type of each method call in the 851 projects. After type inference, only 610 projects were considered as the target projects for our stream usage study. All the files of each project were analyzed, and method calls were classified as follows: stream factory, stream intermediate operation, and stream terminal operation. And pipelines were defined as a sequence of method calls that followed the following pattern: a stream factory, followed by a sequence of intermediate operations, and ended by a terminal operation. The 610 projects and the stream usage were categorized as follows. All projects were categorized into one of the two categories: frameworks, libraries, or tools, and regular applications. Then, pipelines were categorized into two categories, depending on the processing type. In order to answer the question, what is the stream usage trend, the presented bar plot shows the number of projects created by year, and the portion of these projects resulting from the keyword filtering and type filtering. The approach of this work estimates that the portion of projects that use at least once the Stream API is about 21%. The figure also indicates that the share is in constant increase over the years, reflecting an incremental and steady adoption of the Stream library by practitioners. Regarding the type of projects that use streams, the presented table shows the distribution of the 610 projects that use streams across the two categories. The results of this work indicates that the majority of projects, 90%, that use streams are frameworks, libraries, or tools, rather than regular Java applications. In order to answer the question, what are the most used pipelines, the figures presented show the most used stream pipelines of the 610 projects in the dataset. The most frequently used sequential pipeline is stream map collect. This indicates that developers frequently use streams to process data from one collection to the other. The most commonly used parallel pipelines involve for each map and collect operations. We found that only 80% of the projects create at least one parallel stream object, while the remaining 82% use only non-parallel streams. We conclude that developers rarely rely on parallel processing, despite the large number of features for parallel computing provided by the Java Stream API. And as far as we are aware of, this paper describes the largest effort in mining Java Stream usage. We initially analyzed 10,000 popular Java projects and considered 610 projects for a deeper analysis. And finally, as future work, it is planned to pursue our effort in considering partial stream pipelines. Thank you.
Yeah, so anyone, any question? Anyone, any question? Okay, so if you have no any question, then I will proceed for the next presentation. And the title for the next presentation is Quality History of Past Extracted Method Refactoring. So can you please present?
Good morning. I'm going to share my screen now.
Sure.
Okay, can you see my screen?
Yes.
Okay.
Yes, please.
Good morning, everyone. Thank you for taking the time to be here. Beforehand, I apologize for my English. It's not my native language. So our study is Quality History of Past Extract Method Refactorings. In summary, we analyze a large corpus of 2,712 extract method refactorings gathered from 200 Java projects. Our objective is to explore the usage of the extract method refactoring in Java in order to gain insight on how this refactoring helps developers improve the quality of their code. Unlike other investigations, we focus on one in particular, known as extract method. Struct method allow developers to take a fragment of code from a method and move it into another method and replace the code fragment with a call to this new method. In particular, our study provides a detailed analysis of the impact of the Struct method refactoring on cohesion, complexity, code clones, code reusability, and method visibility. To carry out our study, we propose a four-step methodology. First, we collect the projects. Then we detect the refactorings performed in these projects, and then we compute and compare the metrics. Each of these steps are detailed below. To collect the open source project, we use the GitHub API, and we collect the 200 most popular Java GitHub projects. The number of stars of these 200 projects range from 2,199 and 2,786. Then once collecting the sample of project, we use a tool called Refactoring Miner to detect the commits where developers perform an struct method. Also, we analyze all the commit history for each of the projects. In total, Refactoring Miner reports 80,842 refactorings, and then we filtered these refactorings and we found 3,059 correspond to a unique struct method refactoring. Then for computing the metrics, as I mentioned earlier, we focus only on the struct method refactoring, so we selected metrics relevant to this refactoring. And we categorize these metrics in four groups: complexity, cohesion, reuse, and visibility. For the complexity metrics, we use 7 metrics: McCabe cyclomatic complexity, McClure's complexity, nested block depth, number of control variables, number of comparisons, number of parameters, and input and output variables. For the cohesion group, we use the metric lack of cohesion. In particular, we use the Henderson-Sellers method. And we measure this metric before and after the extraction. Additionally, to get a better understanding of the cohesion of the class, we calculate these three metrics: number of used attributes, number of internal method calls, and number of static methods. For the reuse and code clones groups, we measure the degree to which a struct method helps to reduce the code clones in the class and how this struct method favors code reuse. So we measure the number of internal calls, which is the number of times that an structured method is called within the class. And for the code clones, we use a tool called Open Static Analyzer, which detects syntax-based code clones, also called type 2 clones. For the visibility group, we count the number of structured methods that are public, private, protected, and static. And we contrast this information with how many these methods are called inside and outside the class. And then to compare the metrics, we compute the previously mentioned metrics in the refactoring method and class before and after the refactoring. This depending of the metric. And it's important to mention that we only were able to compare the metrics in 2,712 instances of the struct methods. And we contrast the metric values, and then we detect if the metric increase, decrease, or remain the same. Finally, in the section results, first we have the complexity results. The figures show the number of times the complexity metrics for the refactored method increase, decrease, or remain the same. The figures show that in most of the cases, the complexity metrics decrease or remain the same. In particular, 1,391 methods reduce their McCabe complexity. However, 194 of them increase their complexity. We review manually these cases where the complexity increase, and we conclude that this method increases the complexity because of additional change beside the extract method refactoring. In summary, our results about complexity confirm that the most of the extract method refactoring help reduce the complexity of the refactored method and therefore of the class. Also, 42% of the extracted method have a low complexity. For the cohesion result, we found that 1,707 classes increase the lack of cohesion, essentially because the recently extracted method don't depend or depend on few attributes of method of its host class. In the left figure, we have the distribution of the number of attributes of the class that the extract method use. We found that 174 extracted methods don't depend on any attributes of their class. In the right figure, we have the distribution of the number of internal method calls that extracted method perform. In total, we have 49% of the extracted methods don't depend on other methods of the class. Additionally, we found that 10% of this method doesn't depend on the host class and may be easily converted to static or moved to another class where they may be more cohesive. For the code clone results, for this metric, we measure the number of code clones in the class before and after the refactoring. For this, we use different code clone thresholds. It varies from 1 to 5. For example, using a threshold of 4, we found that from the 2,712 refactorings, 818 of the classes have code clones. In these classes, 473 of the extracted method refactoring help reduce the code clones in the refactored class. 19% of the code clones remain in the class, and there are 23 of the refactored classes that increase the number of code clones. For the reuse result, we found that 51% of the extracted methods are called more than once. So this extracted method favor code reuse, meaning that, but there are 49% of the extracted methods are called only once and therefore were not reused. In summary, in code clones and reuse category, around 56% of the extracted method reduce the code clones in the refactored class, and around 20% of the class remain with code clones after the extract method. And 51% of the extracted method are called more than once, favoring code reuse. For the visibility results, we found that 54 of the extracted methods are private and 33 are public. The remaining are protected and packaged. We count how many of these public extracted methods are reused from other classes beside the host class. And we found that 22% of the public extracted methods are only used inside their class, and so these methods are overexposed and may reduce their visibility scope. Conclusion. Our findings reveal that 46% of the extract method refactoring help to reduce at least 4 complexity metrics of the refactored method and therefore of the class. 70% of the extracted method reduce the class cohesion. In addition, we found that 10% of these methods are not static and don't depend on any attribute method of their class. Then we found that 56% of the extracted method refactories favor code reusability and help reduce code clones. And last, we found that 54% of the extracted methods are private, while 22% of the public extracted methods are overexposed and may reduce their scope to private. This is all. Thanks.
Thank you so much. Any questions from the audience? So can you tell me one thing that what is your major contribution among in this work?
Could you repeat the question, please?
Yeah, what is your major achievement in this work?
The main achievement of this work?
Hmm.
The main achievement of this work, I consider these findings. Um, I think uh, I sorry. uh,
No, it's okay. No, what do you
okay, I
think
would like.
that
Sorry.
means? What I mean that, what do you think that how you can see that how can you can say it is a major contribution in the academics?
Okay.
These are some values, right? So what is your major contribution in very short? These are
Okay.
the numerical results.
Yes, like other research, we only focus on one refactoring, that is extractive method, so we can provide a detailed analysis of this refactoring and a deep analysis.
Okay, it's well. Any other question, please? Any other questions from anybody? Okay, in absence of the other questions, we are going for the, I think this is the next one is, this is the Dakshan Murthy going to present the time series forecasting the stock market price based on sentiment analysis of social media. Are you present? Dakshin Murthy, you are present. Please unmute your mic.
Hello, am I audible?
Dakshin Murthy, please unmute your mic.
It looks like it is unmuted, but still we cannot hear him.
No, she has not unmuted.
Hello?
It is the last paper, right? Dakshin Murthy.
Hello?
Kartike.
Hello, are you able to hear me?
Yes, who is on the line?
Hello?
Hello.
Yes, can you hear me?
Yes, I can hear you. You can start presentation.
Yes, give me a second, I'll share my screen. I hope my screen is visible.
Yes, it is visible.
Okay. Okay, so hello everyone. My name is Dakshina Murthy. I am from SSN College of Engineering in India. Here to present the project I worked on with my teammates. It is titled Time Series for Forecasting Stock Market Prices based on the sentiment analysis of social media messages. So in our project, we are essentially trying to identify if the stock market price can be predicted based on the public perception of a company by the consumers. I'll get into it in more detail in a bit. So this is a basic outline of our project. I'll start with an introduction. I'll talk about our structure of the modules and the system and how we were able to collect the data required for the project and pre-process it. And finally, how we achieve the sentiment analysis. I'll talk about the results we obtained and the scope for future work. So yes, as I mentioned earlier, the goal of our project essentially was to find out if there is a relation between the public perception and the stock price. By public perception, I mean all of the customers of a company, not just the market stakeholders or the consultants who are engaged in trading, but all of them. The goal was that if any person feels that the products of a company is not up to scratch, that will affect the market overall. Now, in order to carry out the analysis, we focused mainly on the company Apple, and for social media, we use the Twitter website. Now, the reasons for this is Apple is a extremely popular website, right? And its customers are extremely vocal as well, and they are always in the public spotlight, which means there is constant information about them available on social media websites. So we felt that Apple and Twitter, it's a good combination as a starting point for this research. Now, there have been previous studies related to this, but some of the studies, right, they sometimes consider only the messages posted by the well-renowned news websites or the stock traders, or in other cases, they consider an overall activity, like a 24-hour period, and they try to predict the time over that period. Now, some of these have had good results, others, they say that it is not possible to predict or their accuracy was low. Because of that varying result, we are trying to identify how that happens, and our end result was that by reducing the time period from 24 hours to 1 minute to 60 seconds, we were able to find a much better correlation between social media. Let me just move on to the next slide. I'll show how it's done. So this is our overall system structure. So we start with the social media messages gathered from the Twitter website. We perform some pre-processing on it, which will allow us to do sentiment analysis. And from all this data, we are generating a random forest classifier, which will label the tweets as positive, negative, or neutral. In order to perform the classification, some part of this data set, we labeled it manually through a module that we built, which we will talk about in future. But once it was labeled, right, a random forest classifier is trained, and that is used to label all the other tweets in the data store. So we had 2 million tweets in the data store, all of which was automatically labeled by the model we trained. Now, once we have the sentiment available for social media, we are sending it to an LSTM, a long short-term memory neural network, which is well suited for time series analysis, such as stock market prices, because it is able to keep in mind the previous trends which have been observed. So we decided to try it out with this neural network. So the one input for the neural network is the sentiment price, while the other is the stock market price over each minute within the same time period for which we collected the social media. So the network will then give us a prediction of the stock price in the next time interval. So I'll quickly explain about how we achieve the data collection part of it. So there were two main pieces of data we needed. One was the historical market price data. For this, we went to a company called Finam. This is a renowned Russian financial services company. They provide historical intraday price data for all the popular companies which are listed in NASDAQ, which is the stock exchange where Apple is listed as well. So we were able to obtain the stock price within a 60-second gap. I mean, every 60 seconds, what is the current price is given to us by Finam. And the second piece of data is the Twitter messages within the same time period. So for this, we used a Python package called as Twitter Scraper. It allows us to query the Twitter website to get all the tweets posted within a specific time period that contains the search phrase that we want. By using the search phrase, we are able to filter out the tweets which are relevant to the Apple company alone. So data set pre-processing from the Twitter scraper, we obtained 2.3 million tweets over a 3-month time period. So from this, we filtered out the tweets which are unrelated to the Apple company. There were many because Apple is also a common English word. We managed to filter out all of those. And then for other pre-processing, there are tweet-specific messages like hashtags and username mentions, for which we removed only the special characters and we kept the contents as is because it could help us in identifying the sentiment. And finally, when it comes to URLs, right, we kept the domain name of the URL alone and removed the rest of it. We observed that the domain name of the URL might be helpful for us in identifying the sentiment. And finally, we removed the stop words, which are English language words, which are used for grammatical accuracy and don't really add any meaning to the sentence as a whole. I'll show you a small example in the next slide. So this is an example of the tweet which we obtained from the 2.3 million. So we can see that the hashtag is removed, but the letter is kept. And similarly, @Samsung has become just the word Samsung. The URL Gizmodo / the entire URL has been replaced with the name of the company alone. This was done because we think that the classifier could use this extra information to train itself. Now, moving on to the labeling part of it. So out of the roughly 2.3 million tweets, we manually labeled 15,000 tweets, for which we built a small mobile app. The tweets were divided into 3 categories: positive, negative, and neutral. And this app was essentially circulated out to multiple students at our university, and the labeling was crowdsourced. Multiple people labeled the same tweets so that the accuracy would be as high as possible. So in the final tally, we were able to get 7,500 neutral tweets, 4,000 positive, and 3,000 negative tweets. So with all this trained information, we trained the random forest model, for which we used a library called Word2Vec, which generates embeddings for each word in the dataset. An embedding is a numerical representation of each word, which helps us tokenize and train the model. So once we get the word embeddings, we created the random forest using an XGBoost library. Our final score was, our precision score was 90%, recall 88, and an F1 validation score of 90%. Now, to further confirm the validity of our classifier, we also performed k-fold validation across 10 partitions. So here we achieved a mean accuracy of 85.46%. So we feel that the model was good enough to automatically train the other 2.5 million tweets, for which we collected the data set. And finally, this is a small set of examples of tweets from which was automatically labeled. So you can see that very small tweets like Spotify, Apple Music, it doesn't contain any meaningful information, was given a sentiment of 0. In this context, 0 means neutral, 1 is positive, and 2 is negative, which is, I think, missing from the slide. So moving on. So within a minute, we have multiple tweets, right, which could be of any sentiment. And our stock price is for every 60 seconds. So what we did is we collected the tweets across each minute and we calculated the overall sentiment. If it is neutral, it is 0. And for positive tweets, we gave a score of +1, negative -1. And we calculated the aggregate sentiment over that minute. It is combined with the stock market price over the same interval, which is the diagram you see here. Now, so you can observe that in certain cases, like here, you can see that the sentiment value increases, and side by side, just a few minutes later, the stock price also increased. So that was like a heuristic validation that we are moving in the right track. So this combined data set was fed to our LSTM model. So in this, we sample the data every 10 minutes to smooth out the smaller variations, and the LSTM is given a bunch of training examples which contains the data of the last 12 hours. And the value it tries to predict is the stock price after 10 minutes. So it takes the historical data and predicts the future value. Out of this, we had a total of 35,000 examples for which we trained the LSTM for 50 epochs. And these are some of the predictions which we obtained from the LSTM after it was trained. The green circle is the predicted value and the red cross is the true future. So in these two examples, you can see that it was able to predict whether the price is going to increase or decrease comfortably. So to confirm our initial hypothesis, right, which is that the public perception can in fact be used to identify the stock prices, we trained the LSTM with and without the sentiment price. Like here in the graph, we can see that both are present. With this, we obtain these validations, and we also try to train it by removing the sentiment price. By giving it only the stock market price, we retrained it and tried to find out what is the new MSC. MSC here is mean squared error. So for various parameters like how much is the historical data do we send and how often do we sample the data, we calculated the mean squared error with and without the sentiment, and we can see here that the error is always much lesser when the sentiment value is added. So that answers our hypothesis, confirming that the sentiment value is used here. I mean, it is useful to predict the stock market price. Finally, moving on to our future work, we would like to improve the accuracy of our sentiment analysis. There are certain aspects of the tweets which we have ignored so far, which is, for one example, is an emoji. We believe that emoji can give in more hidden meanings, and these emoticons can help us improve the rate of detection for false positives and false negatives. Similarly, we want to add a weightage to message sentiments. which, for example, a tweet from the CEO of Apple should have a more weightage than the tweet from some regular user of the company. Such things we can improve on it. And also we can consider more social media sources, like currently it's Twitter, we would like to add Facebook as well. And finally, we are looking into developing a product using the model we have trained, so that the predictions may be seen in the practical scenario as well. I think that's the end of my presentation. Thank you so much for listening. If there are any questions.
Yes, thank you for your presentation. Dakshinamurthy Karthikeya, right?
Yes, that's right, Professor.
So, you are an undergraduate student or a master's student?
I am an undergraduate student. I have started my job, but two of my teammates who are not on this call right now, they are YouTube streaming. They are watching the YouTube live stream. They are doing their masters, and they are looking
Okay.
into expanding.
So you are working with them, right? Any questions from the
Yes.
authors, please? So what is your major contribution? Because stock markets price-based sentiment analysis, what is your observation which has not been done in the previous studies?
So previous studies, if you ask me, all of the studies have done it on a 24-hour basis. They only consider the opening price of the stock in the morning and what was the price when it closed in the evening. Now, social media provides a rapid amount of messages, right? So within that 12-hour time period, the sentiment of a public can vary rapidly. So we observe that the accuracy of prediction is not as great. So our major contribution is that we identified by reducing the time period in which we monitor the new tweets, which is 6 to 60 seconds, the accuracy has improved further.
Okay, so if any other questions you have, please.
Maybe I can ask a question. There is a lot of models trained for sentiment analysis, especially for Twitter. Why did you train your own model, and did you compare it with existing model of sentiment analysis? There are many.
We did not compare it with other systems, and the reason we trained it for our own system was because in some of the tweet examples I showed, right, there were company names like Samsung and Gizmodo, and we felt that the names of people in the tweets, which is quite common on Twitter. For example, the CEO Tim Cook features in a lot of tweets. Now, some people's names, they are not part of the vocabulary which is present in pre-trained systems. We did not want to lose out on that information because we felt it would make our final answer, how do I put this? It may not be correct is what we felt. So we decided we could keep all the information that we could, which is why we ended up training Word2Vec and the random forest from scratch ourselves, because we wanted our own dictionary of words.
But you could at least filter the messages you need and use or compare your model with existing sentiment analysis model. Maybe some of them are better. Something to consider for your future.
True. Okay. That is we could compare it, I guess, with what other models are existing. We did not do that. We could have to do that in our future work.
Thank you.
Thank you so much, Alok Cortez. I will look into this paper.
It's okay. Any other question from anybody? So thank you so much for your presentation. And in absence of the, I think this is the last paper presentation. We are meeting after the lunch. This is the lunch time. And those who are there, you can go to the lunch. The conference has already organized, but for the online presenters, maybe next year you are most welcome to join the conference physically. So see you at 3, that is what's the time of the next session, 3:15, right? The last session of the ICCSA, 3:15, and hope to see you again and again. Thank you so much for submitting your papers. Okay, I have already given the announcement that there will be minimum one best paper award in the sessions, in the whole sessions, and we will also some of you will be invited for the general publications. You will be notified, and so on. We will progress. So I think we can close the session for the lunch break. Guilio, Buendi.
Sure. So I'm going to stop the live streaming on YouTube now and then
Yes.
close the room. So everyone can leave the room for now.
Yes. Guilio, I think Love will come to the next session, and after then TDSDP, Dr. Mukesh Kumar will be there. So in the next session, I may come a bit late. I have a keynote and I will go for a keynote speech I'm delivering to another conference. But within 1 hour, I will be there, right? So in ISSQ, I can join a bit late around 3, but I will be there, okay, because I had the same time, only for 1 hour. So don't talk. If you will not get anybody, you can start. There are 3 presentations, but Love will come. I'm sure that he will come.
Perfect. No problem.
Okay, because he has one more paper, okay? And there are only 3 papers are there.
Okay, so